Okay, good morning to everyone. I am Jonathan Buenumilla, and with my partner, Esteban Donoso, we will be panelists on this day. It is a pleasure for us. Welcome to you to our fourth and final webinar of the Yakana seminar cycle. We want to know where you are seeing us. Please tell us in the chat, where are you from? We appreciate your participation today. So, add in the comments.
Well, these cycles are inspired by the top 4 topics.
Hi, Motusi?
Motusi from India.
From India.
I don't know Motusi.
Hi, Eduardo Bravo from Santiago.
I don't know.
Thank you to you, both of you, for comment your greetings in the chat. So, thank you, Esteban.
Yeah. Thank you. I've seen Eduardo again. Okay.
Yes.
Well, these cycles are inspired by the top 4 topics that we will address at the upcoming International Student Conference IONS Yakana, to be held next year, hopefully, in Chile. So keep an eye out for the registration process. The link of the official conference webpage will be sent at the end of the webinar. Now, what are these topics? We will have biophysics, environment, astronomy, and quantum applied in optics. We also have professional development topics, which will be mostly the them discussed in this talk, in addition to the previous talk. Finally, we are starting with our talk titled "How to Promote Yourself as a Young Engineer." In this talk, we will discuss the motivation and ways to promote yourself as a young research engineer. Deepak will discuss education pathway, engineering skills, networking skills, and entrepreneurship skills required for research engineers.
Deepak Jain is a University of Sydney Research Fellow with a strong interest in optical fiber technology and its applications. Prior to this, he was a Hans Christian Oersted co-founded Marie-Curie Research Fellow at Technical University of Denmark. He obtained his PhD degree from Optoelectronics Research Center at University of Southampton in UK. He is serving as a chair of OSA Optical Fiber Modeling and Fabrication Group and also Ambassador for 2020. He has more than 60 publications, including 23 journal publications and several invited conference papers. He also serves on technical committees of a prestigious conference, and he is a senior member of the Optical Society. You should know that Deepak is in Delhi, India. So good evening to you. Thank you very much for joining us today. Welcome, Deepak. We invite you to start your presentation.
Thank you, Jonathan. Thanks a lot. Thank you, Esteban, for inviting me. And can you just enable me so that I can share the screen if you stop your screen sharing? Okay. I think it should be fine now. Thank you. I hope you can see my screen. So, good morning, good afternoon, and good evening, depending on wherever you are. My name is Deepak Jain, and today I will talk about how to promote yourself as a young engineer or a researcher. I will try to deliver a generalized talk so that depending on your profession, you can use it, like the lessons out of this. So don't worry if you are an engineer, if you are an undergraduate student, or if you are a PhD or an early career researcher. So there is something for everyone in this talk. My name is Deepak Jain, and I am currently a University of Sydney Research Fellow at School of Physics and Sydney Nano in Australia. I'm also OSA Ambassador for year 2020. So OSA Ambassadorship is a is a program of the Optical Society where they select early career researchers to share their experience with the PhD students, master students, and the early career researcher. So that is why I'm delivering this talk, being part of this OSA Ambassador. So we are supposed to visit different student chapters physically, but because of the COVID, this is happening virtually. Other than that, and I also encourage all of you to be a part of this OSA Ambassadorship. Once you are done with your PhD, you can apply. Other than that, OSA has 44 technical groups, depending on the different expertise. So one of them is the fiber modeling and fabrication. I'm one of the chair of that. So if you're interested in optical fibers, their design for different applications, and if you want to be participate in some events, we do many events, so you can connect with me. These are my email IDs here, so feel free to connect with me whenever you want. So in this talk, I will talk about why optics and photonics, what's the importance of the photonics, and why photonics is future, and the contribution of photonics towards the mankind. Some example. So you can see this example as an engineer, or you can see these examples as a researcher. There's something definitely to draw from here. Education pathways, tools that you must learn, what makes a good researcher or engineer, scholarships and fellowships, their importance, participations in the conferences, how to write good research proposals, and taking the lab innovation from lab to the market, like how to convert your product, how to convert your findings in the lab to market. Some early career grants and startup accelerator programs and societies you must join. So there won't be much technical, so just relax and enjoy the presentation. So why optics and photonics? Why it is important? Actually, if you see carefully, you will find that the fundamental properties of light and exploiting them for practical application, almost all the applications, like from entertainment to medicine to defense and communication, is being used. So if we can communicate today, despite this pandemic is going on, it's just possible because of the internet, right? And that is all because of the optics and the photonics. If you go into imaging, if you go into spectroscopy, defense, and optical electronics, everywhere they are being used. Optics is like the basics of light, which involves everything. And photonics is more the technical aspects of the optics, using the basics of the optics and develop machines, designs, and the complete setup so for a particular application. So last century was about electronics, and this century is about photonics. And those who are undergraduate students that don't know about photonics, photonics is a branch which involves the study of the photons and exploit the light. Basically, light is made of photons for different applications. So it's more applied compared to just optics. So as I said, like photonics is the future, and the last century was all about electronics, and we see a revolution, like the way electronics did a lot of good job for us. But this century will be more about photonics. There are reasons for that, because see, microelectronics, where we see microelectronics in terms of chips, there are a lot of components, small components on a chip. It's not very energy efficient. In order to process one bit, it takes a picojoule kind of energy it consumes. So if we see 5% of the total electric power generated is being used in the data center and telecommunication centers for processing the data. So microelectronics is a limiting factor from growing data because of the energy consumption. And there's also a limitation to the Moore's law. I'm sure some of you must be knowing the Moore's law, which is like number of transistors getting doubled in a certain period of time. So, but now that is not possible. So when it comes to the photons, like they consume only 1 femtojoule of energy in processing one bit. So they are much faster. As you know, the fastest thing which can travel in this world is the light, 300⁸ meters per second in a vacuum. So photons are fairly fast, super efficient. And that's why photons are being seen as a future of transmission of data and processing the data compared to the electronics. So the message to take home from here is that the photonics is the future. And that's why people are talking about quantum computer, which will be based on the photonics and all that. And one more thing, like light beam can cross each other, so no insulation is required. But as you know, no two electric currents can cross each other. So that's another advantage with the photonics. So this is just to show that the photonics is important, and it's good time to do further studies in the photonics. So if you want, you can continue that. So now giving you some examples like how the innovation, engineering, and the research has revolutionized the world to motivate you to pursue higher studies and to do research. And it's not always necessary to have higher studies. You can also do good engineering just after engineering degree. You can work in a company, you can do good research and development there as well. So let's talk about the Nobel Prize 2014, which was given to these three gentlemen, Ishamu Okashi, Hiroshi Amano, and Suji Nakamura. So these three gentlemen come from Japan, basically origin of Japan, and these were awarded the Nobel Prize for inventing the blue light emitting diode. It's very interesting. Like one might ask why the inventors of blue light emitting diode were awarded Nobel Prize. Why not the red, those who invented the red blue emitting diode or a green one? So actually what happened, the first light emitting diode came to the market was the red one, and then there was the green one was also available, but blue one was not there. And if you combine these three colors, red, green, and blue, you can generate white light, right? So the aim was to develop the white light, but only two colors were initially available, red and green. So it was very hard to generate a blue color by using these light emitting diodes. And these three gentlemen tried gallium nitride. They were growing pure gallium nitride in their lab, high quality gallium nitride, which can generate blue light. So, and they were awarded a light for Nobel Prize. So why? Actually, if you see, in ancient time, we use oil lamp in different cultures, like in wax in India, oil in different cultures to generate the light. So if you see the efficiency, like 1 watt of consumption delivers only 0.1 luminance of the light. Similarly, when Thomas Alva Edison invented the light bulb, it generated nearly 16 luminescence for 1 watt. And afterwards, fluorescent lamp came in 20th century. It again increases the efficiency from 16 to 70. And blue light emitting diode, if consumption of 1 watt, will deliver 300 luminescence, which is great, basically. So you can see it's a dramatic progress in the efficiency. That is why these guys were awarded the Nobel Prize. So if you see, 20% of the world's electricity today is being used for the lighting. And if we replace all the light source with the LED, this can be reduced to 4%. So 16% of the electricity can be saved by using this invention. So this is such a great contribution to the mankind. And this is somehow we can also do if we work hard and use all science and engineering that we know. And let's talk about the impact, like how it is affecting our life. So imagine the countries where still we don't have the electricity access to the students. So suppose if they have a lamp with a light emitting diode and solar cell panel, small solar cell panel. So in the daytime, they can charge their lamp, and in the night they can use it. It can be of very low cost. And other than this, like LEDs are being used everywhere in automobiles, lights, in household lights, in traffic lights, and other fancy computers and our television sets and all that. So this has completely revolutionized the life. But as you know, scientists always ask for the future. They are never satisfied with what is the current state of the art. So what's the future of light and light sources? So Professor Malin Suryevich group at MIT is looking back into this filament-based light. Actually, you know why these bulbs have the lower luminescence, lower light, because they are based on the filament. When light passes through the filament, it emits light in two ways. One in the visible range and another is the heat range, infrared range. So we don't see the infrared light, but we feel that. So if you have ever used the light bulb, you must have feel the warmth. So actually what they are trying to do, there is a visible light, which is good enough, but they are trying to convert the infrared light into the visible light. So by using metamaterial technology, so that the infrared radiation will be reabsorbed and re-emitted as a visible light. So this this shows that it can increase to the 40% luminescence efficiency. Currently, the LED's luminescence efficiency is 5 to 15%. Now, the next technology I will talk about is Li-Fi. All of us use Wi-Fi, we know that, which is like wireless transmission of the data. And Li-Fi is again the wireless communication of the technology, but it is through the light rather than the radio waves. In Wi-Fi, we use the radio waves. Here we use the light as a source, as a carrier velocity, as a carrier wave basically, and which via modulated light source, like some parameter can be modulated to transmit the data. So the advantage of Li-Fi over the Wi-Fi is that there are no electromagnetic interferences as we have in the radio waves, and it's harder to intercept than the radio waves, right? And LEDs are cheap and safe. Of course, one can use a laser in place of LED to make it much faster. And of course, the laser chips can be modulated at much faster connection. So I won't go into the detail. The idea here is to give you like how light is revolutionizing our life in the future. And just to give an example of entrepreneurship, Professor Gerald Haas at University of Edinburgh invented this Li-Fi technology, and now this is being commercialized, right? So this is how you see that the innovation from the lab is being commercialized, and this is one Indian guy again. His name is also Deepak, who is doing this in India and Estonia, basically. So one more example I would give you is of electricity. Electricity is wireless transmission of electricity. So WI came from wireless, and wireless transmission, TR came from transmission, and ECT came from electricity. So wireless transmission of electricity is like you have a source and you have a receiver. So you can transmit the light, not the light, sorry, electricity without wire. So if you see here a coil which acts as a source here, and another coil which acts as a receiver. And there's no connection between them, but still the bulb is glowing. And this is happening because of this wireless transmission of the electricity. So what happens? So that's the basic principle here. When the two coils are at the same frequency, they're in the resonance. I'm sure you must have studied this, a very basic principle. So they can exchange the energy. Therefore, light is being exchanged, sorry, electricity is being exchanged from the transmitter to the receiver. So this was invented by Professor Marin Soljevich, you can see here in the middle with his team. And they patented the technology, and now Electricity is a big company in the US. Now I will give you my example of entrepreneurship. So while I was at the Technical University of Denmark as a Hans Christian Oersted Fellow, I worked over the different high power fiber amplifiers to pump the nonlinear fibers to generate broadband superconductors. So this box was designed by me. You see different components here. So this is what I assembled, and finally it has been converted into a company, Nordlis. Nordlis is Nordic Broadband Light Sources. 3 research fellows, including me and my professor, started this company. We raised 500,000 Danish crowns as a soft money. I will explain you what is soft money. Soft money is the money which you don't need to return. If you approach someone, we have a high-tech idea, and we want to materialize it. So there are some agencies, government-funded agencies or universities, which give you this money. So you don't need to return this money. So it's not like a bank loan. And it's a company now, okay? So I'm just giving an example, like if you have some good ideas, you can take it forward. So now coming to the education pathway, you do undergraduate degree, and especially when it comes to optics and photonics, not many universities offer basic programming at undergraduate level. So it's okay if you are studying electronics, if you are studying physics, applied physics, depending on what your university offers. But if you have done some basic courses in optics and photonics, that is fine. Like something electromagnetic wave, fiber optics communication, and introduction to photonics and lasers, those kind of courses will be helpful. So of course you do a master's, PhD, some postdoc work, and then you go to the academics. So when you go to the academics, many people think the professor only teaches, but that's not true. Actually, what they do, they translate the knowledge, what they have, they do teaching, they do generate new knowledge. So second job is the generation of new knowledge by research. right? They publish paper, they supervise student, and translation of the newly created knowledge to the market. That is the commercialization part. That is known as the spinning off or spinning out or licensing. Suppose you have filed a patent on an innovation, you can give license to some company so that they can carry forward that work or they can use the technology, or you can spin out yourself. As I gave an example of Whiteley City or Northwest where people started the company on their own. So don't think academics is just about teaching or research. There's a lot is involved if you are interested. So doing entrepreneurship or high-tech entrepreneurship with academics is possible, and many people do that. And other than that, you can leave at any time. Just after undergraduate degree, if you feel, you can leave. After master's degree, you can leave. After PhD, and after postdoc. So industrial entrepreneurship is always open for it. These are some of the skills that you must learn nowadays. So if I just talk about optics and photonics, then Comsol multiphysics is a development software which you must learn. And if you see job openings over the LinkedIn, you will find that companies ask for languages, C, C++, and all that, right? Java, if you know these sets. But if you look at the companies in photonics and optics, they ask for these softwares nowadays. GMX is wonderful software for optics design. If you want a job in optics company, you must learn this software. And MATLAB is like evergreen. It's useful for everything. So you must learn MATLAB, Comsol multiphysics, GMX. It's not necessary to learn all, but if you can learn one of them, Cadence and GNX are important for your electronics, microelectronics, chip design and all that. I'm not into that field, but they are very important tools, and you'll find several other. So my idea here is to, like, you must learn some softwares during your studies because these days they are very important. So other than that, I will talk about some personal things, like somehow where you can develop yourself personality the way you need to be in order to be successful into these careers of engineering, high-tech engineering or research. So be curious, ask questions. It doesn't cost you any money, right? It doesn't harm you. So I have met one of the fantastic scientists in my life, and the one thing was common in them, that they were asking questions. They were not accepting the things as it is. If someone is telling them, they won't accept it. They will ask the question. And optimistic. Most of the things that you think is not going to work in the lab, even if you're an engineer or a research fellow or whosoever, because things are different in practicality and things are different when you think in your brain. Okay, so they're not going to work in the lab in the first attempt. You need to make several steps. You need to dig out why this is not working. Learn from a failed experiment, right? Some people call failed experiment to be smart experiment, where you can learn why did it fail. So an experiment should never be a failed experiment. You must always learn something from that. Okay, you found the way why it got failed, then you improve your setup or whatever it is to make it successful next time. I will tell you one thing, like I talked about the Nobel Prize in light emitting diodes. So I had a chance to meet Hiroshi Amano, who is one of the 3 Nobel Prize winners. So in his talk at a conference in San Jose, he said, I think 500 times he tried to grow this light emitting diode. So I asked him, like, how many times one should try? He said, try till you get the success. So number doesn't matter, like if you are doing 100 attempt or 200 attempt, but just keep trying. Third thing is the avid reader. More you read, more you know. So see, when you will grow, you need to know a lot more. And then you can build another block over that. So what I mean to say here, that if you already know a lot, then only you will be innovative. If you know already the current state of the art, what is already known, then you will be able to invent something new. Otherwise, if you find something which is already known, you will say it's new, but it's not new. So what I mean to say, like, read as much as you can. So read 2 papers before sleeping. This is my rule of thumb. If you read, that helps you in getting good sleep and also increases your knowledge. So being innovative is directly proportional to visionary. So more you read, more innovative you become, and more innovative means you become more visionary. So this is a rule of thumb. Develop great writing skills. Might be you are a good engineer, but if your writing skills are good, you need to write report, you need to write research papers, and you need to write proposals. At some stage, you need to bring money to your company. You need to bring money to your research group. So you need to write the research grant. So you need to be very good writer. So these are the skills which you need in your personality. Other than that, apply for scholarships and fellowship. See, your profile has to be very good. And even at undergraduate level, you will see many opportunities to apply for scholarship of, like maybe it might be of small money, but you apply. Wherever you see an opportunity, apply. And same applies to the researchers, Marie-Curie researchers, PhD scholars, like wherever they see opportunity to apply for a fellowship or scholarship, you must apply. I normally give an example, like when we say that a picture is worth 1,000 words, especially when you write the answers to the questions in your exam, it is normally advised to add pictures, or if you're writing an assignment or any article for a magazine or anything. So adding pictures add value. So similarly, having scholarship and fellowships on your CV adds a lot of value. So what it shows that you have a capability to bring money to the system. You can bring money. And remember, money is most powerful these days. Like you can, if you have lots of money in your laboratory, you can hire people, young people, you can buy equipment, right? So similarly, if you are running a startup, if you get good grants, soft grant as a side, so that you don't need to return the money, and then that can dramatically enhance your company. So for a young researcher, or a scholarship and fellowship is worth of 10 publication in my view, right? As an academic researcher or entrepreneur, you need to raise money. So apply. Wherever you see an opportunity, apply. Normally people say these fellowships are very hard to crack. I know they are hard to crack. And of course, they are looking for the leaders in the community, but always apply. Don't be afraid. Whenever you see an opportunity, apply. If your proposal has got rejected, ask for the feedback from the agency or from your colleagues or whoever you are connected with. Try to implement that feedback and submit it to the other scholarship or other, or wherever you see. Other than that, participations in the congresses. Participation in the conferences is very important. Whenever you see an opportunity in your area, participate. If you see you can't travel, there's a money constraint, try to participate virtually. Or if you can't travel abroad, just try to find out some possibility within your area. And OSA is a good thing. Like if you're connected with OSA Foundation, that gives an opportunity, many opportunities to attend different conferences in the different part of the world. So that is another advantage of being OSA member. So what conferences offer? Why one should go to the conference? Doesn't matter whether you're an engineer or a researcher. So depending on your profile or field, whenever you see an opportunity, you must attend. So that gives an opportunity to present your work, right? So if you present your work and there are like hundreds of people attending the conference, that will get good attention. So that's a good way to do marketing of your work. You meet new colleagues, you learn from your colleagues, you do networking sessions during the conference like this, and you basically get an opportunity to know what's happening in your field, in academics, in research, and in most of the conferences, you will see the exhibitions where companies are exhibiting their products. So you will also learn what's happening at the industry front. Build collaborations. You need to build the collaborations, like you need to see what facilities you have got in your hand and what facilities your colleagues, those who are in the conference, has got. So you need to find out like complementary facilities so that you can find out some good collaboration and you can enhance what you are doing. And it is also a good place to find the jobs. Most of the OSA conference these days comes with the job fairs like OFC, CLEO, where you can go and you can meet the industry, because people from industry come there to exhibit their product. And as I said, it's a good place to learn about the technical products from exhibition. Attend several networking and social events. OSA conferences do have many networking and social events. So this way you can increase your networking skills and the way how you communicate with others, and you build connections in different countries. So just to give you an example, I will give you an example, like there's a Lindau Nobel laureate meeting in Germany every year where the speakers are the Nobel Prize winners, and attendees are the young scientists, those who are under 35. You can be an undergraduate student, you can be a master's, PhD, or a postdoc. So I went there in 2019, June. You can see me here. So what happened that you can see this picture with Professor Donna Strickland. She's a Nobel laureate in ultrafast physics. So I said to the professor that I want to visit you. I want to visit your group. And I will show you in the next slide what was her answer. And this is Global Young Science Summit meeting in Singapore. Again, here the speakers are either the Nobel laureates or Millennium Technology Prize winner or Fields Medal winner. Field Medal is in the mathematics that is given every 4 years, and Millennium Technology is given in the more in the advanced technology. So again, the students, attendees are the students, undergrad, masters, or postgraduate student. So this happens in Singapore every year. This happens in Germany, in Lindau. And there is an interesting story behind this conference in Germany. Actually, during the World War II, most of the scientists left Germany because of the Hitler. So in order to attract back the scientists to the Germany, this conference was organized. So this is a very conference being organized from all times, like 50s, 60s. So now let me show you the impact afterwards. But few things are important, like, okay, you got the money to travel from OSA, from your university, from your supervisor's grant, but it is very important that you do homework before you go there. Conference programs are usually available online beforehand. So use your time, try to attend as many as events possible, which are of your interest, where you see there's an opportunity to meet the speakers and all that. Ask questions, this is very important. Suppose if I'm delivering a talk and there are 3 questions after my talk, so I will remember who are these 3 students, right? If you have asked me a tough question, I will remember you. So it is very important to ask questions. If you want to connect with the people, ask good questions, right? Healthy questions. Try to deliver a talk in the conference if you see an opportunity. And if you are going to, suppose from Santiago to you're visiting somewhere in San Francisco or Rochester or elsewhere in the world, could try to see an opportunity. If you see some university in the same city, go and visit that university, deliver a talk, visit their facilities. So, and rule of thumb, like if you're doing good work, if you're developing a company, if you're building a product or whatever, always be ready to speak your work, about your work. So you should have the presentation and slides ready. So whenever you meet someone, you can present your work, okay? And if the conference program is available, you can shortlist the researcher and the participant that you would like to meet. You can fix lunch and dinner meeting with them. So if you go to a conference for 4 and 5 days, this should be completely packed and your program should be ready beforehand. Okay, go through the abstracts, plan questions that you want to might ask during the conference. So that in that way, you can make a lot out of the conference if you go there, because it's obviously very expensive one. So now I will show you outcome of the conference. So as I said, I had a chance to speak to Professor Donna Strickland, who's a Nobel laureate in 2018. When I went to Germany in 2019, I said, Professor, I want to visit your group for a few months. May I come? So she said, okay, why not? So she gave me a letter of support for one of my fellowship. And this is on the right side, you see, I had a chance to speak to this guy. Okay. And they said, we have developed this kind of fiber. I said, why don't you give me this fiber? I can make a device out of this, a superconductor device. And this way I established this conference, this collaboration on my own. And you see a published paper here with me and other colleagues. So between Denmark, Technical University of Denmark and Singapore. So this way, if you go to the conferences, you speak to the people and you make connections. So conferences is not just about hanging around or for sightseeing. If you go there, you do your job for 4 or 5 days. Of course, after that you can go out, there's no worries. Other than that, some general advice, there's no harm in asking. Ask questions, connect with the people through emails if you feel they can help you. If you write 100 emails, one might reply, and never feel shy for asking questions. I do write to a lot of people, and you won't believe many of them has replied to me, and this way I have been able to develop a strong network. So do that. And nowadays, when because of the restrictions we can't travel, most of the conferences are virtual. For example, CLEO is going on. I think it will start today or tomorrow. So you can attend that, it's free. it's absolutely free to attend CLEO. So there are many other say conferences which you can attend. Other than that, I would like to give an example. Now I'm starting a company where I have spinning out some of the novel optical fibers. So, and this is me, one of my colleague, and these two guys, I have never met them physically, right? Dr. Simon Poole is the inventor of the optical fiber technology, early inventor. He's a very big guy, and you see AO here. This is like a third highest civilian honor by Australian government, and he has been the director for the Finisher Australian New Business Venture. Now he's a co-founder of a company, Slide. So I learned about him. I wrote to him that I want you to be on my company's board, business development board. I need your assistance there. He said, okay. And we had recently a Zoom chat. So I don't know him personally. So, but I had the courage to approach him and I could bring him on my company. Now I would like to give another example of Dr. Peter Schulz. He has done a great job. Actually, he was the first guy during his postdoc in 1970s when he developed a very low loss optical fiber. And he was awarded the US National Medal of Technology. This is the highest award given by US government. So I approached him through emails only, okay? Would you like to be on my business development advisory board? He said, okay, why not? And these two are my colleagues. So this was just to show you an example that if you know how to connect with the people, if you just approach, if you have the courage, then people will be connecting with you. So don't worry about that. If you don't know, slowly you can connect with a lot of people. And regarding the company, I said, I told you about provisional, I told you about soft grant money. I won 63,000 Australian dollars from University of Sydney, where I had an idea, where I filed the provisional patent and to start this company. This is soft money. I'm not supposed to return this money. And I'm also looking forward to participate in several other programs. I will talk about those later on. So now I will talk about the research proposals, like how to write the good research proposals. Some of you might find it a bit boring because if you're an undergraduate student, but this is very important. You might need to write research proposals as an engineer as well, if you're working anywhere, if you want to raise funds, or if you have an idea and you want your company to work on your idea, to fund your idea so that you can start working, or if you want to start your own project. So funding agencies are looking for the emerging leaders in the field, right? They are looking for the leaders. They are not looking for the common man. So you need to convince them that you are special. Second thing, don't diverge too much from your current research topics. So you need to have a track record. Okay, you have done something already in this field and now you want to take it further. It should not be too much diverging. You have a track record of doing something in electronics. Now you're talking about biophotonics, something like that. So they want to see that you are the right person on this planet. You are the only person who can do this project, okay? And it should be compelling and convincing case. It should not be the case where you get too ambitious, where you talk a lot, over promises, but under delivery. Feasibility is very important. Remember in mind, those who are going to review your proposal, they are expert in the field, right? And they know this human tendency to overwrite, to make over promises. So it should be ambitious, it should be compelling, convincing, and feasible. Make sure you involve the students at the House Institute. If you are a PhD student, if you are going to do a postdoc and writing a proposal for a postdoc, make sure that you involve the student. Team always do better than a single person, remember. Talk about the mitigation strategies. They like this, like if plan A fails, what is your plan B? Okay. Collaboration, traveling, and networking is very crucial. So keep that in mind. As I already spoken a lot about collaborations, traveling to different conferences and different groups across the globe, that is very important. So you need to mention that during this project, I will be doing this, and that will involve collaborations, traveling, and networking. Your proposal should be easy to read. It should be easy to read. It should be engaging. It's your job to make reviewer read it, right? So let me tell you one thing, like if a movie is being nominated for Oscar, it's the producer and the director's job to convince the jury to watch their movie. They may not watch all of the movies. So you need to make your project, your proposal attractive in a way that people are going to read it. Justify your skill sets, that you already have some skills. You are already a bio person if you are writing a bio proposal. You have already done some part of that before. As I said, mention the collaborators. Okay, I will be working with these guys. Try to use the equipment already funded by same agency and mention this fact in the proposal. Okay, so that's good. Nowadays, web presence is also very, very important, because if you're writing a proposal, reviewer don't know you. They know you only through your web presence. If a company wants to hire you, nowadays Google is available. So everyone who does a Google search. So everyone wants to look at you. So it's very important to have the web presence. You need to make community aware of what you are doing. Even if you're an engineer, if you're developing something, what you are working on. It's a good idea to have your own website. There's no harm in that. ResearchGate is a portal like Facebook, but for the researchers. OSA LinkedIn groups are also great platforms where you can post about your group. Google Scholar, you need to have a profile, talks, and lectures over YouTube if you are delivering some talk or lecture. So, okay. OSA student chapters. So, already you are a part of this chapter, so I will give some advice that how you can make better use of this opportunity. So, make your chapter active. Invite people. OSA has given you a fantastic opportunity where you can approach any leading researcher. And nowadays, since it doesn't involve traveling, and we have these lovely platforms like Zoom, Google Meet, Skype, or whatever, Microsoft Team, ask them to deliver a talk to your student chapter. Make a program every week, organize one talk. This way you will learn a lot, you will get a chance to interact with the researchers, and you might get some position, PhD position, postdoc position with them. Organize events like this one, organize more events. This helps to build your strong CV. So suppose if you are applying for a OSA Ambassador position, and if you already have a strong work, if you have done for your student chapter, then it's very likely you will be accepted, because they want to see whether you have the volunteering capability, if you have the leadership skills or not. So this is very important. So make your chapter active. These are some of the grants which are available across the world. These are very interesting grants, like LIHUEN Fellowship in UK, Humboldt Fellowship from Germany. You can apply that. There's no deadline. All across the year, you can apply. Marie-Curie Fellowship. This is difficult to crack, but you can apply for that. This is one Discover Early Research Fellowship from the ARC Australia. They are more for the postdocs, anti-presidential fellowship. So I understand there are not many PhD students, but if you are interested, we can talk about that later on. But there are many fellowships. And similarly, you will find more fellowships for masters and the PhD. So try to explore. I would say try to move out of your country for a while, work there for a while. That will increase your skills. Now, in this part of the presentation, I will talk about taking the innovation from lab to the market. Like if you are interested in doing high tech or deep tech entrepreneurship. See, a good idea can change the whole world. We all agree. Like we have seen the way life has been revolutionized. So if we have some good ideas, if we have some proof of concept working that this idea works, then file a patent. Patent can make you very rich, remember. If you are after money, that's one way to make a lot of money. Hard money versus soft money. I discussed about soft money. So if you are an entrepreneur, suppose, and you want to start a restaurant, then no one will give you free money. No government will give you free money. But if you are deep tech, if you're coming up with some high-tech product, then you can approach your government for some soft money, which you don't need to return. Hard money is something which you need to return. Soft money is something which you don't need to return. Remember, soft money is only for initial grants when you start your business. It's not for forever, but it's just to have you a takeoff. Okay? Blue ocean market versus red ocean market. Blue ocean market is a market where you see already competitors are there. So suppose if you start, okay, I will start manufacturing laptops. Already there are big players in the market. But, so there's a big competition. Big giants are already there. But the advantage is in the sense that you know that there is a market for this product, right? On the contrary, suppose if you're coming with some new product, absolutely new product, then you are entering in the, sorry, I messed it up. So blue ocean market is a market where you come up with something very new, where there are no competitors. Sorry about that. So it's absolutely new, but there's no guarantee that there is a market. On the contrary, in the red ocean market, you already have the competitors. For example, if you start a business of laptop manufacturing, you will say already there are the computer sellers in the market. So there's a huge competition. But the good thing is that you have a market. So in blue ocean market, you are the first one to move in. You come up with some deep high-tech product, which is protected by the patent. So you are the first mover, you have the niche, and you have a lot of advantages. But disadvantage is that you need to make sure that you have a market. Nowadays, many mentoring programs at the proof of concept grants are also available from the universities. So this is, suppose you have an idea of a product, you want to make sure it works, so you want to test it in the lab. So you can apply for grant from many universities have different schemes. So you can apply for that. This is how basically the high-tech business and scientist works. And choice is yours, whether you want to do a job to fix someone's window or construct your own window. Sometimes people ask me a good question, whether do I need an MBA degree for business? Like many people say doing a master's degree in business administration helps. I would say no. You just don't need to waste your money and the time. There's a simple formula, like profit is equal to the selling price minus cost price. You need to somehow keep this high. So that is all about MBA. This is what people learn in the business school. And another important thing is the pitch talk. Suppose you have an idea, very interesting idea or some product that you are working on. You will go to a venture capitalist. That guy will say, okay, you have 5 minutes, pitch your talk, pitch your product. So pitch is a very important word in the business world, especially in the startup world, where you pitch your product. The problem that, so you can get a very limited time in this, for this pitch talk, like 5 minutes, sometimes it is even 2 minutes. So in this 5 minutes, you have to convince the venture capitalist or the reviewer that you are doing a good job. There's a business in your product. They are not interested in learning about your product much because they are not technical people, but they are interested in learning what's the business in your product. So normally in a 5 minute pitch talk, you have 5 to 10 minute maximum. You need to talk about the problem that you are solving and the solution you propose. You don't need to go into the physics of that. You just need to talk about the box. Okay, this is a solution and this can solve this problem. They trust you. Value propositions for users, customers, how useful will be your product, market size, very important, opportunity, description you may give or you may not give, but sales distribution, the revenue model is very important that you need to talk about, like if realized, what would be the revenue model of this product, like how much money you can make, how will you start with year 1, year 2, year 3, right? And what's the unique about the technology, USP, unique selling propositions, competitive landscapes, you need to talk about your competitors and teamwork and whatever groundwork you have done, you can talk about that. If you have done some market research, that is also very, very important because you might think your product is good, but someone has already might have tried and failed. So if you learn from others, okay, what your experience, then you can save a lot of your time. So the best way to do market research is to conduct surveys, use Google Form, ask people to fill it for you, use LinkedIn, approach the companies whom you think can be your potential customers, interview them. You need to know that what problem are you going to solve for your customers. Thoroughly scan your competitors, check if someone has already tried or failed. Remember that they are hiring you for a problem. I would like to give an example. When Uber started, they did a market research, and when they spoke to people like, what stops them from hiring a cab? They say that we don't know how much will be the price, and the cab drivers sometimes generate higher bill and they ask for more money, so they are not sure. So Uber found the solution that if the customer knows the bill, approximate bill in the advance, like from traveling this point to this point, I will be paying this much, that will convince them to ride a cab. And this is what happened. Like in Uber, you can see how much is a tentative fare for a particular ride. And Uber is very famous, very successful. You can see it around the world. Minimum viable product. So if you are thinking about entrepreneurship, if you have some idea, I think it's a good idea to have a minimum viable product ready, small proof of concept ready before you go advance. That will convince the reviewer, okay, you have something ready in your hand. Now, just something more about hard funding and soft funding. As I said, hard funding is about loan from the bank, where you take money from the bank, which you are supposed to return after a while. Venture capitalists, there are many capitalists who invest in your company, but after that, they own some part of your company, which is equity. And similarly, there are angel capitalists and self-funding. You can do your own funding, you can bring your own savings. But if you are in the high-tech business, in the deep tech business, we use proof of concept grants, government-funded schemes, and career accelerator programs. Career accelerator programs are programs where they do give some free money, equity-free money. And another way to raise money for your idea or for your product is the crowdfunding. There are different portals where you can talk about your product and you can aim, okay, I want to raise $100,000 and let you request everyone to contribute $10. So, but tell in detail about your product, what it is going to help the society and all that. So this way you can raise money through crowdfunding. Blue ocean market, which is red ocean market, we already completed that. Just like in the blue ocean market, there are no competitors, there's no direct competition, but no existing market. You need to have your patents, otherwise someone will come and steal your technology or your idea. On the contrary, in the red ocean market, there's a jungle of companies, huge competition. But some of the example, like in telecom, this are from Indian perspective. There are many companies, insurance, it's full of companies. So you won't get soft money for this market. Soft money will be given only for the blue ocean market because the funding agencies want new technology to develop. That's why they are giving you the money. Accelerator programs, what are they? So actually what happens, you participate there. So normally they are organized by some organizations, some societies. So they give you like an idea how to take off in the beginning. They offer mentoring support. And they also sometimes give some money like $10,000, $100,000. There is a limited money, but a good amount of money for a new startup. So nothing in the pocket. So there are many. One of the organized by SPY is a SPY Startup and Entrepreneurship Program. One is Hello Tomorrow, Illuminate. These are more in the optics, Illuminate one. And you will find several of them, depending on your country, your location, your university. If you want to know more about business, entrepreneurship, then you can attend OSA Innovation School. This is a very fantastic opportunity given by OSA. This has happened, I think, this year or will take place in July. You can check the OSA website. So this is a 4 or 5 day program where you learn a lot. This is virtual because of the COVID. Otherwise, normally you visit the place. And this is also very subsidized, very low cost, like $100. Some of the societies which might find worth joining, we already know about OSA. We can also talk about SPY or IEEE Photonics Society. They offer different kind of support, travel grants, different networking events and all that. So access to the publication and all that. So thank you. I'm done, I think, and I'm happy to answer any question at the moment. And you can write me to your email ID if you have any question. And if you are interested in knowing about fiber design, modeling, and application, you can join our Facebook group as well. I would be happy to add you there. And you can add me over LinkedIn as well. Thank you very much.
Thank you very much, Deepak, for your presentation. There were very important tips to have in mind. It was a clear instruction to have a starting point.
Sorry?
it was a clear introduction to have a starting point. So you are now invited to write down your questions. You can write in English or Spanish, and we can translate if you want. So leave your questions in the Q&A section, so Deepak can solve them.
So should I read the question first time?
Jonah, you are silent.
Jonathan, you are muted.
You're muted. Yeah.
Sorry. Yeah, Motusi is asking, what is the best way of building up networking?
Okay, I don't think there's a one best way. You have to try all the ways, as I said, like participate in the conferences, approach people. Wherever you see an opportunity, you try. And sometimes it may work, sometimes it may not work. So, but try your best, I will say. And yeah, attend the conferences. That's the wonderful way of making, having a network. And participate in these events, these kind of virtual events, like you are doing right now. And these days, of course, we don't have the conferences. So just wherever you see people, go there and introduce yourself. And I'm sure some will always be interested in having a network with you.
There's another question. What is the boundary line between visualization and promises during grant application?
I'm not sure if I understand this question completely. So what's the boundary line between visualization and the promises? But I can understand you're talking more about like the promises you make in an application and how feasible will be that. So if that is, this is what you mean. See, like, as I said, like you need to have a strong track record of what you have done in the past, and your proposal should be aligned with that. So I can see like this candidate has experience of fiber modeling or any device modeling, let's say, of fabrication and doing some characterization, some experiments in the laboratory. So you will be able to see, okay, this guy has the potential to perform this experiment or to fulfill this proposal. So that is very important. So whenever you write a proposal, it should be close to your area. It should not be too far. And you should talk about mitigation strategies, like if it fails, what I have plan B, plan C. The collaborations are very important. If you choose the right collaborators, okay, these guys will help me in that way. And if they fill the gap, like if you don't know X, Y, Z thing, and if you bring right collaborators, okay, you know A to X, but for YZ, you bring appropriate people on the platform, that would be helpful. So always remember, if you submit something and which is not accepted, you can always ask for the feedback from the agency. So this way you can improve. And sometimes it is also a lottery, basically. So it's not like that whatever you will submit will be accepted. That is my answer.
Okay, thank you. Another question. Do you think it is possible to work in optoelectronics nowadays without a PhD degree lab?
Yes, why not? It's definitely possible. Just after your undergraduate degree, you can go there. So it's not like PhD increases your chances. It's PhD is more for your research and development jobs if you are highly interested. But for companies, for industry, even an undergraduate degree is perfectly fine. As long as try to have internship in a photonics company during your degree, a small internship that will help you, and try to learn the skill set required during your degree.
To continue the question is our technology is still low developed and we have to wait a few more years.
No, actually technology is developed, fully developed in many areas. And of course, always the case, like some parts are developing and some domains are yet to develop. But yeah, some parts are highly developed, as I said, LEDs, lasers, semiconductor components. Many things are already in the market, and companies, there are well-established companies having like billion-dollar markets. So definitely it's well-established technology, you can go there for us. Intel is one of them, like they're working on silicon photonics. So having future processors with the photonics.
So we will see future technologies in the upcoming years.
Yeah, absolutely. Why don't you will see? You see, internet is there. It's just photonics basically, right? It started in 70s, 60s, and now they're completely based on internet. And people are talking about quantum computers nowadays. So all will get better with time, and we'll see a lot of progress.
Any other question? I think no. See, that was the last question.
Okay.
Well, Deepak, we want to thank you again for your time and guidance on the subject.
Oh.
And thank you very much for participating in the Yakana seminar cycle and your willingness to teach us too.
My pleasure.
We appreciate the participation of all who joined us in this morning and this side of the globe, and good evening to you in that side of the world. We invite you to follow us in our social media to find out when we will have new activities for you.
And finally, we would like to thank for their collaboration, sharing this cycle to Facultad de Ciencias USACH, Departamento de Física, BIM USACH, Radio USACH, CEIF, REDIF y Comisión de Divulgación Científica. There are Chilean groups and the first 4 from our university. And if you want to rewatch this talk or share it, you can watch it on our YouTube channel. Have a nice day, and we hope to see you in the future activities.
Bye.
Thank you.
Thank you all.